Before we talk about division, let's talk about a step in simplifying quotients of radical expressions that might seem a little bit weird. Let's talk about rationalizing the denominator. Are we helping the denominator come up with plausible excuses for doing whatever it really wants to? No. This word rationalizing means writing without radicals. So when we're rationalizing the denominator, we're arranging our expression so there are no radicals in the denominator. And of course we want to write not just any old expression with no radicals in the denominator, because if we could write whatever we want, we'd just write like 7 or something. We want to write an equivalent expression. All right, this seems like a really weird thing to do. Why do we do it? Well, the reason that we rationalize the denominator is fundamentally the same reason that we do any sort of simplifying. Why do we simplify expressions? We want to be able to look and see if they're equivalent. We want to be able to look and see that two expressions are equal if they are, or that they're not equal if they aren't. So we pick one form to be the simplest form. We make the choice that we will call the simplest form of an expression with radicals the one that has no radicals in the denominator. Now there are other reasons to do this other than we just pick. Sometimes it's nicer to work with something rational in the denominator. But for our purposes, we have to pick something, and this is the one we picked is enough. All right. Now that we've answered what and why, let's answer the question you've been waiting for. How do we rationalize the denominator? Well, in order to rationalize the denominator, we will multiply the numerator and denominator by the same thing, and we will choose that thing so that when we simplify the denominator, no radicals remain. And because we don't like to introduce a bunch of extra stuff, we will always choose the smallest expression to multiply by. What do I mean by smallest? The one where the coefficient is the smallest number and the variable expressions have the lowest degree. Now, we can have some super complicated denominators. For our purposes today, we will only rationalize denominators with a single radical as their only term. All right, so we have our very general plan of action. Let's see a specific example and make our plan more specific. Let's say we want to rationalize the denominator in this expression, 3y squared over 8x to the 7th. My first move is going to be to factor the 8 into primes because prime numbers act just like variables. I'm not going to be concerned at all with the numerator for most of this process. Right, so 8 is 4 times 2, 4 is 2 times 2. So 8 is 2 to the 3rd. Okay, now here's the tricky part. We want to decide what to multiply by so that each exponent is a multiple of 4. Why 4? Because our index in this case is 4. So let's see. 3, the next multiple of 4, well, I need one more 2, right? So I'm thinking 2 to the 3rd times 2 is 2 to the 4th. And 4 is 4 times 1. I'm thinking x to the 7th times another x is x to the 8th. And 8 is 4 times 2. So I need to multiply by, it needs to be inside a 4th root so that I can combine it with this root. I need one extra 2 and one extra x. Okay, and now we're going to do that. I want to multiply the denominator by the 4th root 2x. So I'd better do the same thing in the numerator. Now I actually do the multiplication. I've got the fourth root. 2 times 3 is 6, x, y squared. And in the denominator, I've got the fourth root. 2 times 2 cubed is 2 to the fourth. X times x to the seventh is x to the eighth. And then I simplify the denominator. And at this point, the radicals should be gone. So what do I have? Numerator stays put. Denominator, I'll have fourth root of 2 to the fourth is 2. Fourth root of x to the eighth is x squared. And that's it. That's the denominator rationalized. I'm going to give you one of these to try now. Remember, the tricky part is this decide what to multiply by step. We need to have every exponent in the denominator be a multiple of whatever the index of our radical is. Rationalize the denominator of this expression. Pause the video and try this now. All right, so we're going to start by factoring 9 into primes. But 9 is just 3 times 3. So I'll have the fifth root of 3 squared times z to the 11th. Now, after 2, the next multiple of 5 is 5. So in order to make the power of 3 a multiple of 5, I have 2 now, I need 3 more. After 11, the next multiple of 5 is 15. I have 11 now, I need 4 more. 2 plus 3 is 5, 11 plus 4 is 15. That's why I chose those numbers. I multiply the denominator by this thing, I've got to multiply the numerator by the same thing. All right, so now I do the multiplication. 2 times 3 cubed, I get 54. And then x, y, z to the fourth. In the denominator, I'll have the fifth root, 3 to the fifth, z to the 15th. So numerator stays the same. Fifth root 3 to the fifth is 3. Fifth root z to the 15th is z to the third. And there's my answer, denominator rationalized.